What do you know about area, perimeter, volume?
Well, I know how to solve like the perimeter area and volume. Volume is for like 3D shapes. Perimeter, I know how to solve the perimeter for uh different shapes like triangles, squares, circles, and area as well.
That's right.
Basic
What is the difference between perimeter and area?
perimeter is just the outside, and area is like the full inside.
That is the full inside. Outside, inside. So what if I say perimeter is just the length?
Length of the whole outside, right?
And area is the region occupied. Yeah, length of the whole outside. For example, we talk about a fence. So the length of the fence would be the perimeter, and the space enclosed inside the fence would be the area of the land occupied. Let's talk about some few basic shapes and then we'll continue with the topic. Okay, let's say we have this first shape and name is square. To find the area, square has four
Length
sides.
times width.
Length times length. So that is length square and the
And
perimeter will be 4 times length. Rectangle.
rectangle is length times width for area,
Very good.
and 2L plus 2W, basically, yeah.
Very good. Okay. So triangle.
Area is height times width. It's still length
Like,
times width, but
one
it's the
more.
height.
We'll call it 1 by 2 into base into height.
Oh, okay. Yeah.
Let this be the base, and height
Mm-hmm.
is always the perpendicular one with the base. And perimeter general formula is a plus b plus c. Why so? Because we
Mm-hmm.
have 3 different sides and we are adding all 3 of them. Okay, now some different shapes. What do we call this shape?
A trapezoid?
Trapezium, trapezoid, yes. Trapezium. So perimeter would obviously be sum of all 4 sides. And what is the formula for area?
Is it's still the with the base.
This
So
is
one
by
1/2
1 by
times
2
base times height.
sum of parallel sides, also called as side 1 plus side 2 times height. And these are the parallel sides. One side is this, other side is this, and distance between these two parallel sides is known as height. You know, you also have access to this OneNote sheet, right?
Sorry?
You have access to this sheet, right?
Oh, I do? Okay.
Mm. Yeah, I'm not like stopping you to write.
Mhm.
Definitely, once you write it, something that will be in your long-term memory. You can always write the important ones. This is the email address on which,
Yes.
if you want, we can add another one.
Oh, yes. Can you add my mom's because my dad doesn't sometimes share it with us.
I have it. I'll quickly do that. Done.
Okay, thank you.
You're welcome. And you'll find it somehow like this. Oh, this is your name. You'll be
Mhm.
able to access every one of this thing. So
Okay.
if you like, if you just wish to see any other topic, these are A levels and so on, you can do that.
Okay.
And if you want the relevant topic, this is your name and these are the topics.
Okay.
Okay. So trapezium this. In your later time, if you wish, you can take out the screenshot, you can make notes. During the class, you definitely do make important notes. Okay, this is trapezium, that is this. And now we have different few more shapes. Then we'll turn on to composite shapes.
Parallelogram.
Okay, that's parallelogram, but I'll change it on purpose. This. If you are given with this information, what would you do? What will you call it? There's a
Was
slight difference between parallelogram and this. Let me draw that. You'll feel the difference.
yeah, it was like the mix of a parallelogram and a square.
Yeah.
But then
In
but
parallelogram, we have two pairs of opposite sides which are equal and two pair of parallel sides. But in the shape drawn above, that is
rhombus?
rhombus.
Rhombus. Mhm.
So a rhombus is area is base into height. Now you have to be careful with this. This complete length is the base. Height is the distance between these two parallel lines. Height and base are always perpendicular for whatever shape we talk about.
Mhm.
This again is base and this is the perpendicular distance. Area is again base into height.
Okay.
On
Wait,
the other
how do you
side,
know how much of a tilt it has to be?
dimensions would be given.
Okay. Okay.
If you're finding, for example, we are talking about this and let's say I'm given that this is 8 and this is 6. So area would be 8 into 6. I don't know what the tilt is, but definitely when we keep on covering the topics, there's one topic known as trigonometry. Trigonometry. Heard about that?
Mhm.
So in that case, we will be knowing some of the information is given, some is missing. So let's say we are known that this is 60 degrees and this is 8. So we can apply trigonometry and find this vertical height. And then to find the area, we'll be multiplying 8 into this height.
Mhm.
Okay. For now, we are considering journal shapes and considering that it has given. And perimeter is again adding all four sides. So if I've written B there, I can write 4B. And in this case, this is B, this is again B, and these two sides are unknown. So let me generally write it A, B, C, and D, sum of all four sides.
Okay.
Now we talk about composite shapes. I'm not moving towards circle. How is this a composite shape? What is the name of this shape?
Height.
Kite. And how is it composite? These are two
Two
different
shape.
triangles attached. So we call it composite shape. So we already know what the area of triangle is. And for the perimeter, we have four sides. A, B, C, D. When we
For the area, did we just do like the triangle formula twice? For each
twice,
triangle? Okay.
1 by 2 into base into height. And then for this one again, 1 by 2 into base into height, and then we add them.
Okay.
So let's have a look at the this scheme.
Volume for 3D shapes.
Yeah, we'll move on to that.
Mhm.
Once we like have a little practice of this, we'll move on to 3D shapes. Let me quickly show you that too. That is very easy. If you have a strong grip on 2D shapes, what volume looks like?
Length times width times height.
Yeah. If this is a cube or cuboid, base would be length into base area. Base area would be length into breadth. So whatever is the base area, or we call it cross-sectional area into height is the volume. So you already know the area of the base into height is the volume. So when you look at this shape, that's a circle and area is pi r square. And if you look at the 3D shape, that is a cylinder.
Mhm.
So 3D shape volume is area of base times height.
Yeah.
Look at this parallelogram. We already know that area is base into perpendicular height. Now if I extend it backwards, try to make it 3D. Now this is cross-sectional area into this new length. So volume is already the cross-sectional area, whatever it is, into the new length. So any shape into length, any shape into length. Let's say if I talk about, I'm holding a shape that is a triangle.
Mm-hmm.
And I extend this triangle on the other side. So I'll multiply it with that length, cross-sectional area into that length. So let's say this was the triangle and area is 1 by 2 into base into height for this. So what would be the volume of this 3D shape? This is this cross-sectional area into this new length or height, whatever we call it. I'm just trying to have different variables. So volume is cross-sectional area into height or volume is cross-sectional area into this length. So that would be basically this area, which is 1 by 2 into base into height. This base is for that triangle. This height is for that triangle into the overall height, which is between these two. So either you call it L or you call it this new height. So cross-sectional area into height. This is the difference between 2D and 3D. If you already know the 2Ds, we can multiply it. Now we also have some different kind of 3Ds. For example, a pyramid that changes its cross-section area when it is moving upwards. For example, we talk about a cone. We just talked about a cylinder.
Mm-hmm.
It was same throughout at the bottom and top. It was same. But if we talk about a cone, a birthday cap, that is the circle at the base but changes at the top. Still, what do we have for volume? Cross-sectional area 1 by 2 base into height for triangle into this height and overall divided by 3. For this pyramid, what did we had? Pi r square is cross-sectional area into the height. And for cone, what do we have? Cross-sectional area into height, but divided by 1 by 3.
Okay, so every single one that's like changing at one point, you always divide it by one, times it by 1/3.
Yeah. The volume reduces 3 times.
Okay.
Example, we talk about this. The base is square and it stays as it is till the top. So volume is length into breadth into height. New introduction, this green point. Now the base is this square and we have a point at the top. So base was square. That should be length into breadth and height should be this thing same, length into breadth into height. Now because we have it converging at one point, this is the difference. See,
Mm-hmm.
all of this stays same. When it converges at the top, we add a constant 1 by 3. Volume reduces 3 times.
Okay.
Okay. So let's have a look at few of these points. Perimeter area, irrational number, are you familiar with these? Perimeter, we have already discussed that, and we will go into some practice questions. Area, what is irrational number?
Irrational numbers are numbers like fractions, decimals, negative numbers.
You've switched it.
Mm.
What you're talking about is rational, and irrational is other than fractions,
So like
other than
pies
decimals,
and like repeating decimals.
repeating decimals. Yes, this is that number which you cannot write in exact form. For example, exact value of pi cannot be written. For example, the exact value of square root 2 cannot be written in decimal or in fraction. So simple definition would be pi in non-perfect square roots.
Mhm.
For example, square root 16 is a perfect number, that is 4. But square root 13 is not perfect, so this is irrational.
Mhm.
So, sector and arc. What is a sector and what is an arc?
A sector is just like a section of a circle that goes through the midpoint.
Remember,
Yeah.
this is the sector. These are the segments.
Mhm.
Sectors, segments, and what was the arc?
Arc is like the outside area of the circle.
The outside length,
Length.
length.
Mhm.
So this right here is the minor arc.
Mhm. And the rest is the major
The rest
arc.
is the major. And what would define major and minor is 180 degrees. If it is less than 180 degrees, it is minor. If it is more than 180 degrees, it is major.
Mhm.
Okay. Semicircles are half of circles. Solid is 3D shape.
Mhm.
Net.
Mhm.
Ever heard this word net?
Yes.
Can you draw a net for any 3D shape?
Okay. I can draw one for a square.
Like the options choose from yes and no.
Oh, yes.
Okay. So what we'll be looking at, we've discussed few 3D shapes. Mostly it comes out of those. And somehow, sometimes we already have a complex shape and 60% of it is drawn and we have to complete that 40% part.
We need naturally.
Vertices, what is known by vertex? Okay, we'll discuss vertex, face, and edges. I think I've discussed it with someone earlier. I can't remember if it was with you or someone else. Let's say I have a perfect cuboid,
Mhm.
cube, all sides are of equal length. Let it be a 3D shape. Consider these blue lines in the background. Vertices, edges, and faces. Faces or planes. How many are these?
Eight vertices?
Vertices, 8, correct. Edges,
16?
16. No,
12?
12, yes.
And faces. 2, 6.
Correct. Once we know what we are talking about, we can always find it. Should be clear about the questions. So vertices, faces, now surface area. We already know what area is. We talked about the volume. What is this surface area? Again, we will consider this as composite shape. Suppose we are talking about a cube. We know we have 6 faces. So we are individually find area of 1 and multiply it with 6.
Mm-hmm.
If we have a shoebox, we have 3 different types of areas. 2 of the sides are rectangles of same size. Top and bottom are rectangle of same size. And the side towards us and away from us are rectangles of same side. So total surface area or surface area we can find individually and add them together. Volume is okay, and apex and slant height. Okay, apex is the topmost point and slant
Yeah.
height is this height if you can see it in this image.
Yeah.
This is not the vertical height, this is the sloping height.
Mm.
Okay, we've discussed these areas, formulas, and we normally go about 2 pi r. Is it clear? The difference between pi d and pi r. Diameter is basically 2r.
Mm-hmm.
So when we write 2 pi r or we write 2r into pi, you can replace 2r with d. So that is the circumference. Area of square, rectangle, triangle, circle. Volumes of the same. This is the cross-sectional. If you look at just the base, area would be base into length into height. So cross-sectional area into height. This is the cross-sectional area which is pi r square. So pi r square cross-sectional area into height. So volume of cylinder would be pi r square h. Volume for this object is this cross-sectional area into this height. Why are they not writing it generally? Because this h and h would be confusing which height are we talking about. So we generally call it volume is area of cross-section into height.
Okay.
Perimeter area in 2 dimensions. Okay, we have these shapes. We've discussed these areas. Base into height. Height is the distance between 2 parallel lines. Parallelogram, triangle, trapezium. Okay, some extra shapes. First one is kite, we discussed that. But when we look at regular hexagon, there are 2 different approaches we can see. One, I'm splitting it into 2. Do you see 2 different trapeziums?
Yes.
So we can find this trapezium and this and then add them. One approach. The other approach is, because I know it is a regular hexagon, regular means all sides are equal or angles are equal. So if I just split it into all 6, now I can find area of one triangle and multiply with 6. That would be very easy because we know all these angles are of 60 degrees each. And if I'm given with this base, I can find all the other lengths and the height using a bit of trigonometry. We haven't discussed that yet. We'll see what type of questions are there, what type of difficulty level is there. Once we study trigonometry, these questions will be easier because we will know more formulas. For example, one of the formula for this triangle, let's say this is 11, this is 7, and this angle between them is 60 degrees. So it is simply 1 by 2 into first side into second side into sine of 60 and done. You have the area.
What is sine?
That is trigonometry. I just gave you a touch that once when we will study it, these will become more easy. Okay. we will study sine, cos, tan in trigonometry. You would have seen that those buttons on your calculator. If
I
I
know.
SAN, COSTAN. Okay, and units are obviously when we are talking about meters. So meter into meter is meter squared. Length is singular, no power. Length is meter. Area is meter square. Volume is meter cube because we multiply three different dimensions. Okay, this is the word example. Let's try some. Perimeter. Try this D part.
Eight. Mm, 38.
Let me check that. That is 10 plus 9 plus 2 plus 2 plus 8 plus 7 is 38. Oh, very good. So you knew that this section was 8 and this section was 7. Okay. Mm, okay, let me just ask you the missing sides. What is this length?
8.4.
8.4. And this
The 1.9.
1.9. And this length.
That length is.
Do you want me to zoom in?
Yes. Mm, 1.9? Still? No.
Yes, that is 1.9.
Okay.
Now, do you just when you just look at these, but just by looking, will anyone accept that this is also 1.9?
Doesn't look like it because those look
Yes.
smaller.
These are always given not to scale.
You can't measure it. It's not going to be the same.
Yeah, you cannot measure them. You can find them, but you cannot measure them.
Okay.
Okay. So I'm not asking other questions because those are still simple the add-ups. Simply the add-ups. Okay. There we go. For area of this B, we have the formula area is equals to base into height. So the base is 5
But
and the height is 3. So we'll be
15.
given with these values. What is the area of E?
So it's just the base and the height again, right?
Yes.
So 16.
So 8 into 2 is 16. That's right. Okay, I'll share this with you, keeping in mind one day. It would be short and I deliberately want to keep it less, keeping in mind that on Monday we'll have a short test.
It's-
And if you wish to ask anything out of those units, we can definitely practice them tomorrow.
Okay.
So, but I'll still share some questions from this topic. It is always like better to practice what we studied freshly.
Mhm.
Anything you would like to ask?
No,
Take care.
thank you.
Let me display these two. Okay, displayed all three of them. Let's go through them one by one.
Okay.
Okay, so what problem are we facing in this topic?
And this one was question 6.
Question number 6. Okay. Question 6 says, how many 20 centimeter by 30 centimeter rectangle tiles would we need to tile the outdoor area shown below?
I know for this one, I need to find like the area of this shape and turn like all the numbers that are giving me into like centimeters. But when I was doing it, because this is not like a normal shaped like shape, I separated into like 3 different shapes, cut it into the sides.
Okay, that's one way. That's right. What if I just convert this into meters, or I convert those meters into centimeters for a bit fair comparison? If I write like 260 centimeters in case of 2.6 meters, for 9.9 meters, I'm writing 90 centimeters. This is 4.8, that would be 480 centimeters. Now I'm going to write the missing lengths. That is 1.7, which is 170 centimeters. And we are not sure what these two lengths would be because no discrete separation is given. Now let's try. It says tiles are 20 centimeter by 30 centimeter. I'm just checking if I can divide this 260 by 20. So 260 by 20, it goes 13 times. So I know if I would place tile which is 20 centimeter on this side and 30 centimeter on the other side, I should be able to place 13 of these tiles in this order. And if I get to place 2 of these, in fact, that is unknown. Let me come right at the bottom. So 480, if I divide 480 by 30, I'm getting 16. So I'm placing 16 of these tiles in this way. Let me write it separate. So I'm placing 13 tiles in this way. We're placing 16 tiles in this way. 480 by 30 is 16. And I'm checking for this 170. If I divide 170 by 30, that is a decimal number. So I cannot place full tile across 170. And if we go for 170 by 20, again a decimal number, we'll have to cut it. How many 20 by 30 centimeter rectangular tiles would you need to tile the outdoor area shown? That's 0.9. If we split this up, and 2.6 minus 0.9 is 1.7.
So that
Let me open up a writing space. Sorry, what did you say?
1.7.
Yeah, 1.7. Controls, writing space. So we've checked it. Either side, we'll have to cut the tile. We are not placing complete tile on any side. 480 20 by 20 is giving me 24. And if I go on the other side for 260 divided by 30 is giving me like fractions. So 20 by 30 rectangular tiles, if we are placing them like this, it was already there. 13 tiles will be placed in this way if this is 20 centimeter each. So 20, but we do not know what this full length is. And it is the area shown below. It is not drawn
Not
to
spec-
scale. That is 1.7, 4.8 minus 1.7, and we are left with 3.1. So 3.1 into 100 is 310 centimeters. 310 is not divided by 30. 310 is not divisible by 20 either.
3.1 into, we have to divide into two of the spots, right? Or can we just do it like normally, just dividing it?
I just feel like information is missing. This is 480. This is 260. This is 170. This is 90 centimeters, 90 centimeters. And this is 260. And there should be something given if we just take those equal. 480 minus 170 is 310. And if they are equal, or if this is like 150 and this is 160, 150 plus 160 is 310. Now let's try to fit those tiles. 150 divided by 30 gives me 5. So 5 of these, 1, 2, 3, 4, and 5, and 13 on this way. So this will complete this region by 5 into 13. Are you any confusion with this 5 and 13? Where is this 5 and 13 coming from?
No, 260 divided by 20 gives you
Yeah,
13.
30
And
this way
yeah.
and
And
20
then
this way.
150 divided by 30
So
is add that way.
this region is 13 into 5 total tiles plus. Let's come on the other side. So 260 divided by 30 is decimal. 260 by 20 is again a full number. And up to 150, only up to 150. And let's say this region is left behind. We'll deal with it later. So again, 5 into 13, another 5 into 13 tiles. Now in between, I have 170 in between, and other way, this is 260.
How is it 5 into 13 tiles again?
I took the same dimensions,
Mm-hmm.
150 and 150, and left this 10 for later calculations.
Okay.
So this is 150 and 150, and again, so these are complete tiles. Plus, now I have this length as 170, and total was 260. So 260 minus 90, remaining is again 170. 170 by 170 on both sides. So if I just place 20 centimeter on this vertical direction, 20, 20, 20 again. So 170 divided by 20 is 8.5. So 8 complete and 1/2.
Mm-hmm.
8 complete tiles and 1/2. Would say that this is 8, and then on the other side that should be 30. So 170 divided by 30 gives me 5.6. So that means 5 complete. That would be till 150. That would be till 150. This is like we are covering 160 by 150 and still left 20 centimeters on this side and 10 centimeter on this side. We'll have to cut those tiles. So this is 160 by 20 is 8, and on the other side is 5. So 8 into 5, this region. So we are done with 1, 2, and 3 regions. Now we have to cut these tiles. This is 10. So if I just lay those tiles, so this would be, that is 20 into 160. This is 20. and this complete is 160. So 160 divided by 30 decimal tiles. So we'll need more tiles. Wastage would go aside. We need more tiles. So I'm just bringing this remaining region outside, 2 and the 3. These 3 regions are outside. Now, if you see, this is 10 centimeters.
Mm-hmm.
If I use that same tile, which was 30 centimeter by 20 centimeter, and if I cut it into 3, I will be able to use this one piece here, which is giving me vertical 20 centimeters and horizontal 10. And already how many pieces am I getting? 260 by 20. I'm using 13 of these pieces. So 13, 3 pieces are coming out of one tile. Another 3, 9, another 3, 12 pieces. So 1, 2, 3, 4 complete tiles and one piece, 1 by 3 of the piece. We'll deal with it. Now this side is 160 centimeters and the width is 20. So if we just rotate the tile to the side, that we are using 20 fully on this side and 30 over here. So 160 divided by 30 gives me 5.3. So I'm using 5 complete tiles, 1, 2, 3, 4, 5 complete, and this section is left. So another 5 complete, and this section is left. And I know the exact length, that is 13 to 5, 150. This is 10 centimeters by 20. So 10 by 20 is left. I'll have to cut that. This last section was left. 1 by 3 of the tile, which was 10 into 20 again, left and left. Now this horizontal section at the bottom. Horizontal section at the bottom says this complete length was 150 and 60, 70 and height is 10. So again, we can use these 10 centimeter widths, and 170 divided by 20 on the other side gives me 8.5. So 8.5 tiles will fill this completely. That is another 8.5. Now these remaining are actually 1 by 3 and 1 by 3 of those. So if I add these two,
Mm-hmm.
10 by 10 and 10 by 20, I'm using one complete more tile. So these are number of tiles I will need to fill in the space. So this is 13 into 5 plus 5 into 13 plus 8 into 5
Wouldn't that,
plus,
how would it be one? Isn't it like we're getting like the 1/3 out of it? So only like
I'll
2/3 of
show
it?
you.
Okay.
I'll show you. We know the dimensions. The dimension is 10 centimeter by 20
Mm-hmm.
and the other dimension is 10 into 10.
Oh, 10 into 10.
Sorry, 10 into,
20.
was that? Let me quickly check that. This is 20 and 10. 160, 150, 10. 10 is left on this side, 20. This is for sure 10 into 20. And this full length was 260, 13. And this horizontal length is 10 already. So we needed 10, 3 tiles and one on this 10 into 20. 10 into 20. That is 10 into 20 and 10 into 20. So this is 10 by 20, 10 by 20, 2/3 of a tile. Yeah, 2/3. 1 by 3 plus 1 by 3 is 2 by 3. So that should be 2 by 3 of a tile.
And then we add them all together.
We add them all together. 13 into 5 into 2 plus 8 into 5 plus 4 plus 5 plus 8.5 plus 2 by 3. I'm getting 88.01. So I will be having 189 tiles.
Mm-hmm.
And Let's try it one more way. If we just find the total area and divide by the area of the tile, do we get the same or different answers?
I think finding the total area is like an harder approach, especially when you don't have like the values at the top.
Now, what we'll do, we'll find the area of the complete rectangle and eliminate this blue box
Okay.
because we know the dimension of this blue box.
1.7 and 0.9, yeah.
Yeah, this is 170, this is 90, this was 260, this is 480. So if I just use this 260 times 480, 260 into 480 is giving me 740.
And then we
Now,
see
if I use that 90 and 170, 90 and 170 is giving me 15. 90 and 170 is giving me 15300, and 260 into 480 is giving me, that's a typo, that is giving me 124800. Getting it?
Mhm.
So now we can subtract these two. 124800 minus 15300, 124,800 minus 153,000. I'm getting 109,500. Now this is the area of the floor. And area of tile is 20 into 30, 600. So 109,500 divided by 600 should give us number of tiles. Gives us 182.5. So we are going to order 183 tiles.
Would this one be more accurate?
Yes. Because it is giving us like less cross sections. 183, yes. The second one.
Yeah.
So total area divided by area of the tiles.
Okay.
Which question after question 6?
Oh, SSAT.
Now the one with 2 units.
Yeah.
I didn't get it for checking.
Oh. Oh, maybe it didn't send. Okay.
Yeah. Okay, you may send it today. I'll check it.
Okay.
And pie chart and the graphs.
Mm.
Okay, we were discussing this perimeter area volume, and we did our first exercise. We'll discuss few questions and then we'll move on to the next part. Calculate the area of the following shapes.
Was this the one you gave me for homework?
Yeah.
Okay, okay. Um,
Yes.
sorry?
That's the same.
Yeah.
I said we discuss random questions, then we'll move on to the next part.
Okay.
Okay, for example, we are talking about area of this J part. How would you solve this?
Well, it's 6 plus 12, and then it's times with the height.
Okay,
Or
6, 12, and then times the height.
I
Anything
believe
else?
3 divided by 2 afterwards.
Yes. That is 1 by 2. 1 by 2 into side 1 plus side 2 into height. That is a trapezium. Very good. 4a. How will you deal this?
There. Well, I can change it into two different shapes. A
Very good.
triangle and then a square. Or a
Composite.
rectangle. And then I can do the 8 times the 5, which goes to 40, plus the 4 and the 5 divided by 2, so 10.
1/2 into base into height.
Yeah. So 40 plus 10, which is 50.
Plus 10. That is 50. Oh, very good. Okay, let's continue. Have you been through these questions?
Yes.
Okay. New shape circle. Finding the circumference areas and all. Let us discuss these formulas first, and then we'll come back onto exercise. Okay. So the shape is circle, and it looks like this. Area and perimeter. Special name given to circle is circumference. It is one and the same thing, just a different vocabulary. So circle area is pi r squared, where perimeter is 2 pi r. And if we talk about semicircle is half circle, and the area would be half of that, and perimeter would be pi r plus 2r.
Oh, yes.
Where is this 2r coming from?
Because of the middle part, the
Because
radius.
of the two of the radius is 1r, this second r, and this section is going to be pi r, half of the circle. In the same way, quadrant is 1/4 of a circle. So that would be pi r square over 4. And on the other side, this is going to be 2 pi r over 4 plus 2r, which could be simplified to pi r by 2 plus 2r. Now, in the same way, if we just keep on reducing the size, but this time it is something which is not 180, which is not 360, which is not 90, it is some angle. So we call it sector. Now, if you just focus, this was 180. When we are talking about the semicircle, this was 180. And that was 180 by 360 of pi r square, which resulted in pi r square by 2, because 180 by 360, we cancel it out, it becomes 1 by 2. And so does 90 by 360 becomes 1 by 4. This is where the 4 is coming. Now, in the same way, angle by 360, whatever the angle will be, into pi r square will give you the area. And for the perimeter, we'll do angle by 360 into 2 pi r. It gives you the arc length, this length, plus 2r. Does it make sense?
Yes.
So let's see what the questions are. If we'll encounter a new shape, we'll again come to the writing space. Now, the only difference is that diameter equals 2 times radius. One radius, another radius. So diameter equals 2 times radius, but we mostly use the term of radius in formulas and in questions. So finding the area, we've discussed the formula. Let's jump on to the practice exercise. Again, composite shape. It says calculate the shaded region of the diagram. If we look at the shaded region, that is some a triangle, and we are taking out the unshaded part, that's a circle. So triangle is 1/2 into base into height minus the circle. And picking up the correct dimensions. Base is 18, height is 20, radius is 2.5. And just plug and solve. Okay, calculate the area and circumference in each of the following. Now, if I just look at the first question, this is 4 meters is the radius and calculating the area pi r square. The radius is 4. That gives me 16 pi. Now it will depend on the statement of question. What is the question requiring from us? If it says leave your answer in terms of pi, this is my answer. I will write 16 pi meter square. If the question demands that give your answer up to 3 significant figure or something, so I'm using 16 times pi.
50.4.
I'm getting 50.265. Up to 3 significant figures, it will make 50.3. Okay, so that would depend on the requirement of the question. Question will always state that. Let's try E part, area.
So is it going to be left with like the pi signal?
Anything. For now, I think we should keep it as pi. That would be quick.
So 2 pi? No, 4 pi. Because it's squared.
That is square. And what is the radius?
4?
What is the radius? What is the value of radius?
Uh,
This is not,
pi square root of 2.
that's diameter.
Oh, that's the diameter.
Compare this A part with E part, A and E. See the difference?
Yeah,
That
now
was,
only that part is drawn. Okay. So divided by 2 of the
yeah.
square.
So pi, that is 2 by 4 and finally pi by 2
Hmm.
kilometer square. Try F part.
4 over pi squared times pi.
That's right, 4 over pi square times pi. So we get rid of one of these
Mm-hmm.
and it is
4 over
over
pi.
composite shapes. Calculate the area of the shaded region in each case. So when we look at the first one, if I'm just writing the formula, shaded area is equals to pi r square minus L square. May I write that?
Mm-hmm.
So radius in this case is 9 and length is 2. So that is 81 pi minus 4. Again, it would depend on the demand of question. In this case, I'm like writing them as decimals. 81 pi minus 4 gives me 250.46. So 250 up to 3 significant figures, centimeter square. Try B part.
So it is 64 minus 16 pi.
Correct.
Okay.
So 64 minus 16 pi gives me 13.7 centimeter square.
Pi is 3.14, right?
Pi is
If
3.1. Yes.
if we were to do it in like an equation, not the full thing, but yeah.
Three
Okay.
different pi. Pi is equals to 3.14. Pi is considered as 22 by 7. And the third one is as it is fed in your machine. That is 3.141592654 and so on. Depends on the display capacity. So this is what I'm getting. And when we normally use our calculators, this is what we are using.
Mhm.
So all three are acceptable. 22 by 7 gives you a bit larger value than the other two. That is approximately equal to 3.14285 and so on.
So would it
So
be okay if we were like to use any of them and then like
you can
because some
use,
of them.
because the question isn't stating anything. And the most desired one is the one in calculator.
Mhm. Okay.
Just fed in your calculator. But with 3.14, obviously you will be getting the same answer because that is a difference of 0.001.
Yeah.
When you are pressing these four buttons, it is quick that you press this one. We have that directly.
Yes. Okay.
Okay. So let's try E part.
So 285 minus 25 pi.
285.
Wait,
I'm
I
getting
don't think
230.
I divided it by two, so wait. I don't think I divided by two afterwards. Yeah, 142.5
I did it with 2.
on 25 pi.
You have already divided that with 2.
Okay.
I'm not getting 85. We are getting 32. That is 0.5 times 19 plus 12 times 15. So I'm getting 232.5. 232.5 minus 25 pi.
Yeah, 232.5 and then minus 25 pi. Yeah.
And finally, it gives me 153.96, which we can write as 154 centimeter squared.
Mm-hmm.
F, again, a composite shape.
Mm-hmm. Semicircles and then a rectangle.
Yeah.
Yeah, 36 pi plus 36.
Okay, I am looking at it as one circle when I combine these two. So that is pi r square plus 3 into 12. Yes, 36 pi plus 36. Okay, why do we have these statements? The diagram shows a plane for rectangular garden with circular pond. The part of the garden not covered by the pond is to be covered by grass. One bag of grass seed covers 5 square meters. Okay, so that's why we have statements. Calculate the number of bags of seeds needed to work to be done. Statement questions and nothing else.
Twenty-three.
Correct.
Okay.
I was getting 22.5 and then we converted it into 23. If your answer would have been 22.1, what will you leave as final answer?
22.
Why not 23?
Because you don't have to round it to the next side because it's smaller
Oh,
than 5.
now consider this. Calculate the number of bags of seed needed to work to be done.
You'd rather have one extra so you can fill in the 0.1.
22 is actually not for the complete task. So in this case, we would need 23. For example, we are calculating number of workers and they come out to be 7.3. So we may call 8 workers to complete the task in the given time. If we choose 7, we'll need more time. And if we are like, suppose if this was not bags, if these are like open bags, we may say that we have 22 complete bags and 700 grams extra. So we'll be taking care of that rounding in the context. Okay. Diagram 4 shows the diagram shows a road sign. If the triangle is to be painted white and the rest of the sign will be painted red, calculate the area covered by each color to one decimal place. So we can start with triangle first.
Mhm.
That would be 1 by 2 into base times height.
So 1.
0.1.
0.1. 4. And
Slow
then
and we will
equal.
we will get rid of this problem.
Wait, I don't really understand the question that much. So it's saying calculate the area covered by color to one decimal place. So
By
it's saying just
each,
find the whole area of the circle except the triangle to one
yeah,
decimal.
parts. There are two parts in this question. One is definitely what you're thinking. Full area subtracted the triangle. That will give you the red part. This is white
Mhm.
and red will be full minus white.
We give both of those.
Yeah, we need both of these. Calculate the area covered by each color.
Okay, okay.
If I would over exaggerate and rate you as student, I will say you are always more than 95%. There's only one drawback. You go through the question very quickly.
I rush it.
And one more thing. Use your time. Do you ever play games? Do
Video
you,
game?
any video game? Have you ever encountered that there are cheat codes?
Yes.
What happens if you don't use them? The stage will be harder to clear.
I
So
will not rush anymore, and I will take my time so I can
whe-
make
whe-
questions through.
use all of your resources. Use all of your resources. Calculator is your resource. Time is your resource. For now, for start, suppose we are not sitting in exam. You may, suppose I recommend you that you should be able to complete the question in 3 minutes. I am still okay if you take 7 minutes, but the question is correct.
Hmm.
Rather, we complete it in 30 seconds and we lose any mark. And the painful part is you can do it. You lose just because of hurrying in the question
Yes.
and nothing else. Okay, so first part is 0.1 meter square up to one decimal place, and the other would be pi r square minus, I just copied that white section.
Minus 0.1, 0.36 pi minus 0.1. But then let's do the one decimal place.
Can you show me your calculator? Which one are you using?
I use this one.
Okay. Uh, is that like scientific, the brackets or anything like
Uh,
this one?
I have that one, but it's not like this one. It's not like that. I think I should use that one for like these
Yeah,
problems.
you should use that one for like for example, when we need to use brackets and squares and all,
Yeah.
that would be, and on top of that, that is allowed in your exam.
Okay.
Only the graphic calculator is not allowed. There
Oh,
are ones
yeah.
display graphs on the screen. So sometimes I feel like I can see that you're confident, but the answer is differentiating just because of this error. So I'm getting 1.0309, which up to one decimal place will make it 1.0.
Mhm. So just one. But we have
Let's
to
just,
1.0, right?
yeah, we have to write that to show that to one decimal place it is 1.0. To show the examiner that we have not skipped the instructions. Number 5, 16 identical circles are to be cut from square sheet of fabric whose sides are zero point 0.4 meters long. Find the area of leftover fabric to two decimal places if the circles are made as large as possible. Can you think through the question?
The total area of the square 0.16, so you can't go over that. And the circles, the largest as they can be,
Correct.
two circles would probably fit into it, or one circle if it was
Six,
large as possible. Oh, six,
16
yeah,
identical.
16. So, oh yeah, so we divide that by,
Now the task is to find the radius or the diameter.
mhm.
If you get the radius right, you've done the question. Are you still working for the radius?
Yes.
Okay.
Zero point one. One, no.
What is your thinking process? How are you fitting these 16 circles in this square space?
I'm trying to like think of like one side of it. So with the 0.4, and then
Correct?
I'm trying to fit it into that like four circles in one side.
That's right.
And for each one, radius. So 0.05?
That's right.
Oh.
0.05. Other way, other way could have been just split it into 16 parts. 2, 4, and there you go. Like you don't have to manually do it. This is just this thinking process. So whatever the area is, we are getting 4 circles on one side and 4 on the other side, multiplying, then we can have 16 because it was a square. If it would have been a rectangle, suppose 0.2 by 0.4, I would have thought of 8 circles.
Mm-hmm.
So half on the other side and double on the other side. So they were identical and 0.05, yes. So what are we doing? We are fitting in these 16 circles and eliminating that area. The full area is 0.4 times 0.4 of the square sheet minus 16 into pi into r 0.05 squared. And we get our answer 0.03433. And fulfilling the requirement to 2 decimal places, we have 0.03
Okay.
meter square. Got it? Anna and her friend usually order a pizza. Oh, okay. Whatever the question is, but do know that whenever you go order somewhere, if someone is telling you you've ordered a 9-inch pizza, and whenever we ordered that, these are diameters. You ordered a 9-inch pizza, but the manager came with 2 5-inch pizzas. He said that we are sorry, we are out of the dough, and we are offering you 2 5-inch for the same price. Will you accept it?
Yes.
Okay, now see. When you ordered 9-inch, let me say that costs $20, and he's offering you both of these in $20.
Mm-hmm.
So $20, that means you ordered 9 by 2 squared, this much of area. I'm working that out. 4.5 squared times pi gives me 81 by 4 pi, and in decimals it gives me 63.6 inch square of pizza in $20. Now let's work out this. 2 times pi times 5 squared. 5 square is 25. 25 into 2 is 50 pi.
So it's not equal.
That's not equal.
Yeah, I mean, I was expecting it to be more. So yeah, no.
5. Just a second. I took the diameter. That is 2.5. When it is 5.85 inches, that is 2.5. So 2.5 squared times pi gives me 25 by 4 times 2 gives me 25 by 2. That is 25 by 2, which is equal to 39.26 inch square. Can you compare this?
No.
And and see, even if he offers you 3 5 inches, that's 1, that's 2, that's 3, that will be 3 into pi into r squared, and this gives me 3 into pi into r square. Even then, that is 58.9. That cannot compensate.
So only 4, I guess.
So if he offers 4, that is 78. 4 would be 78.5 inches. And if we just find out the difference, 78.5 minus 63.6, I'm getting 14. Now 14 divided by 63.6 times 100, that is only 23% more. If he offers 4, even 3 pizzas will not compensate the price.
Um,
So whenever you are out with your parents, don't accept that
okay.
or ask for 3.
Oh my goodness.
Now, this was the term which led us to that question. Anna and her friend usually ordered a large pizza to share. The large pizza has a diameter
Oh, 24 centimeters.
of
So
24 centimeters. This week, they went to eat different things on their pizzas, so they decided to order 2 small pizzas. The small pizza has diameter of 12 centimeter. They want to know if there is the same amount of pizza in the 2 small pizzas as one large one.
no,
No. So the
no.
large one is pi into 12 squared. That is 144 pi
Mm-hmm.
centimeter square. And when they work out with the 2 small ones, this is 2 into pi into r. 6 square is 36. 36 times 2 is 72. So that
Seven.
is 75. Clearly, they are not equal. Okay. Now it says exact answers as multiples of pi. That would definitely be given in the question if the exam question requires so. So we are not, just not changing that pi and using it as it is.
Mhm.
For example, for each calculation, give your answer as multiple of pi. Find the circumference of circle with diameter 12. Diameter is 12. So circumference is equals to 2 pi r. Diameter is 6. That is 12 pi. If you wish to use, you can use this formula directly. Circumference equals pi d or 2 pi r. I've always used this to avoid any confusion. And in exam, it is perfectly allowed. You may use any. And so on. We're keeping it as pi.
Yeah.
So let's try these. Find the circumference and area of each shape. Give answers as multiples of pi. So if I just look at the first one,
9 pi.
9 pi, circumference is 9 pi, and area is
Area is 20.25 pi.
That's right. 81 by 4 pi or 20.25 pi. That's right. Work out for this D part.
So 7 pi for circumference.
Circumference
Because
pi r plus 2r.
oh yes. And then
Now just tell me honestly,
yes,
if
because you add the
you
radiuses on
take,
the side.
if you take your time, this would look like 7 pi plus 14 and not only 7 pi. Always take your time.
I think I think I forgot the formula thing, but even if I looked at it, then I could have seen.
You know what the hardest part is? I don't know what if it works for you or not. That is the rechecking part. When you've done your test and someone tells you to recheck it, you still have 6 minutes, you still have 7 minutes. That is the hardest part for students to go through. And area will be
49 pi? No. So 24.5 pi because we divided by 2. Mhm. Wait, but don't we have to divide it by 2?
you already did that. 14 by 2 is 7.
Mm-hmm.
When you do it again, you actually did it 4 times.
Okay. I don't know why I divided by 2 in the first part.
Bad luck that you are rushing through the question.
Okay. So 49.
Questions are, and so they will be in exam. We just have to read the statement carefully and avoid careless mistakes. That's it. Okay, so okay, now if I just look at this F part and let me say that there is no clarity what we want to find. So for the area, find this complete. And then for the perimeter, let us find all the length used to draw the shape. That is 1, 2, 3, and 4 sections.
So we have to find the area of the whole semicircle, and
Yes,
then
semicircle.
also like the lengths of the sides.
Yeah, these two. If we just talk about the circumference of the complete shape, it will be these two lines only. And if the question says that suppose these are steel wires, calculate the length of steel wires, we'll add this last length as well.
Mm-hmm.
For circumference of the complete shape, it has to be the boundary only.
For the area, would it be 21.16 pi?
Mm. Area is pi r square by 2.
Mm-hmm.
Radius is 9.2.
Mm-hmm.
So pi r square by 2.
Mm-hmm.
9.2 squared by 2 gives me 1058 by 25. That is 42.32.
And then don't we divide it by 2, like the 9.2?
We don't divide 9.2 by 2. That is already the radius.
Mm-hmm.
It was pi r square. This is for complete circle, and by 2, this is for semicircle.
Mm-hmm.
So 9.2 squared divided by 2, and that's it. 42.32. 42.32 pi millimeter square.
So
And
after we do like the 9.2 by squared with the pi, and then we divide it.
yeah, this complete thing.
Yeah. Okay. Yeah.
And circumference is this. Nine point two times 2 is 18.4.
And then we can add them together with the pi.
We can add them, but we'll leave it as it is because the question says so.
Pi.
Leave as multiples of pi. Okay. For each of the following, give your answers as multiples of pi. Calculate the circumference of the circle with diameter 10 centimeters.
10 centimeters?
Yeah, diameter is 10.
Mhm. So 10 pi.
Correct. B part says a circle has radius 7 millimeters. What is its circumference?
14 pi.
Correct. What is the area of the circle of the diameter 1.9?
0.9025 pi.
Correct. The radius of semicircle is 3. What is the area of the semicircle?
4.5 pi.
Very good. Question number 3. The circle of Circumference 12 pi centimeters precision cut from the metal square as shown. What is the length of each side of the square? Think you can do it? Very good.
Okay. Because the radius should be 6, so the full one length of it should be 12.
Very good. Radius is equals to 6 and this full length is 12. B part says, what area of metal is left once the circle has been cut from it? In terms of pi.
Yeah, so 144 subtracted by area? Yeah,
Subtracted area.
area. So 36 pi. So 144 minus 36 pi. Yeah.
Very good. Question 4 says, the diagram shows two concentric circles. Concentric means having common center. The inner circle has circumference of 14 pi. The outer circle has a radius of 9 millimeters. Determine the exact area of the shaded portion.
Oh, inner 32, 32 pi.
I'll try quickly. 2 pi r equals 14 pi for the inner one. Pi goes with pi and radius is 7. So inner has a radius of 7 and outer has a radius of 9. To determine the exact area, area would be pi r square minus pi r square. 9 times is 81 minus 49 and 81 minus 49 is 32. You said 32?
Yes.
Very good. So that is millimeter square. Now, luckily, we've already covered this arcs and sectors in different topics. Quickly, arc length is this boundary. We know what the radius is. When the angle is less than 180, it is minor sector. When it is more than 180, that is major sector. So whatever we talk about is angle out of 360. If we are talking about the area, so for area, we'll use pi r square. And if we are talking about the perimeter, it is still angle by 360. For perimeter, we add 2 pi r. This is the difference for area and perimeter plus 2r because it has two more boundaries
Mm-hmm.
that will give us the perimeter and area of the sector. Okay. More composite shapes. For each of the following shape, find the area and perimeter. Trying for B part. For area is angle by 360 into pi r square. So 45 by 360 times 8 squared is 8. I'm getting 8 pi. That is area. And perimeter is angle by 360 times 2 pi r plus 2r. This is perimeter and area for the sector whose radius is 8 and angle is 45. Try this F part.
So circumference is also counting like the two circle lines are there.
What angle are you using for circumference or area? This is a major sector.
Uh-huh. So I have to use 270.
Yeah. Either we use 270 or we use 90 and then subtract it from the complete circle.
For the circumference, it's just we also add the two lines, so it would be plus 2r. I mean plus plus 2r.
Yes.
For the circumference, what I have now is 1.3 continued times 0.56 pi plus 0.56.
That's right. It results as 1.879 without pi in case of perimeter. And what about the area?
The area.
without pi.
Okay, hold up, pi. Zero 0.32. Sorry, I can't hear you.
This would be angle by 360 into pi r square.
Mhm.
So 270 by 360 times pi times 0.28 square is 0.184725.
Sorry, 60, 4.07,
Why are we having different answer? What did you miss?
I'm trying to do it again to see
Sure.
what I missed.
It also depends on the machine we're using. Sometimes we have to be careful to take care of the mass rule. Like for example, if you are just punching all the numbers in the right order, like 270 by 360 into pi into 0.28 and then square, calculator will actually make the square of all the last value and not only 0.28. If you're using a simple calculator, you can also like avoid putting that square and multiply 0.28 two times.
I
And
still
for
get the answer. I don't know. Because for when I do it, I first like divide like the 360 by the 270, and then I times it by like
okay, I'll do it step by step with you. 270 by 360 is 3 by 4. That is 0.75.
Mhm.
Just punch that and do we have the same answer? 270 by 360 is 0.75.
Yes.
And then we multiply with 3.14 and we get 2.355.
Yes.
And then we multiply by 0.28, that is 0.6599. And again by 0.28, we
Sure.
get
It's
0.1846.
32. Yeah. 4.6? Yeah, 4.6.
1846 because we took 3.14.
Mhm.
in this attempt. And before that, I was taking the complete value of this pi, which is already fed in the machine.
Mhm.
Let's try one more from this and then we'll move on. That is D part, area and perimeter.
So would the area be 116.1 pi? I mean, no, 116 pi?
116, that's it.
One
You've
one
already in it.
yeah,
That
one
is 6, and this is 17.2 by 2.
and the
Okay,
circumference.
so that was centimeter square, and the circumference or the perimeter.
I got 71.208.
I got 44.
Okay.
We are having very large difference.
Yeah.
That is complete was 2 pi r. Now
Mhm.
this is pi r only. So pi and r is half of 17.2 plus 17.2, 44.2. I think that would be just because of the machine punching in the right order.
Um,
3.14 multiplied by 17.2 divided by 2, and then later on add 17.2 and you get 44.204.
yes, 44.204.
Okay, that's a cute shape, G part. So area first, and when we look at the area, I am looking through two semicircles. First one, the larger one, is going to be pi r square by 2, and then the smaller one is going to be pi r, in this case will be half of 4.3 by 2. Pi into 4.3 squared by 2 plus 1 by 2 pi 4.3 by 2 squared.
36.2866.
Correct. Centimeter square. And then the perimeter.
.406.
I have 24. Look at these three splits. One is the larger semicircle, arc, then two, then three. So we add these three. When we look at number one, that is pi r only. Pi and r is going to be 4.3. And when we look at the second part, radius would be half of 4.3. And then we look at the third part, which is just a straight line of 4.3. And we add these together.
Yeah. 24 point, yeah, 5553. Yeah, about 24.56.
That's right. Each part is a simple shape, area and perimeter. I've already solved it. Let's see if we get the same answer. Have your school started yet?
No, it's gonna start in 2 days. For the area, I got 98.13. Yeah.
Yeah, you have
And
the same answer.
perimeter.
And perimeter.
For the perimeter, I got 43.42. So basically 43.4.
Very okay. I'll share the next questions for
Mhm.
you to practice, and I'll keep them like keeping in mind we have class tomorrow.
Yes.
And then after tomorrow's class, we can discuss our homework, keeping in mind reopening of schools and okay. And we'll keep in mind your upcoming exams, and someday we'll discuss what we are studying and what you are studying at school, and do we have common topics. And I was planning if we can get like the breakdown for the next term, we can plan to stay ahead of school, 1 to 2 topics.
Mhm.
Whenever your teacher shares with you, we can always like go through this and shuffle them up. There are very few topics which needs prerequisites. For example, it is better that we study angles first before doing polygons.
Mhm.
So that is it, inshallah. We plan accordingly. Anything you would like to ask?
No.
See you tomorrow then.
Thank you. Bye. Oh. Sorry, can I say something?
Yeah.
Oh, can we have the tomorrow's class on Monday instead? Because I have to go somewhere by like 9 o'clock. Oh, okay. Can we do some sorry, 1 second.
Okay.
I have to be somewhere by 9 o'clock tomorrow because I have a science fair. Can we do the tomorrow's class next week at like Friday maybe? If
Okay. Whenever you want this shift, your father can always talk to Sir Kashif. He knows who Sir Kashif is,
Mhm.
Mr. Kashif. The reason is he's the organizer. We're using this Zoom link, and more teachers and more students are also using the same link.
Mhm.
So he would know that if there is no clash, personally, I've got no problem with that. We can readjust. So he's the better resource. Your father can talk to him directly and he'll just give me a text. I
Okay.
would be
Okay, okay.
both of them can talk to each other and it will be done.
Okay. Okay. Thank you.
Welcome. Best of luck for your science fair.
Thank you.
Nice. It was science competition, right?
Mhm.
Did you get time to practice these?
Yes, I finished them.
Any confusion in any of the
No,
questions?
no.
Okay. Okay, next concept is three-dimensional objects. and we'll be talking about nets of solids. What basically a net is. You would have seen mostly at big shops that they roll a piece of cardboard in front of you to pack that cake. So we'll have 3D objects and we'll draw a net of it. For example, if I try to draw a shoebox, for start, let me say that it is with open top, no lid on the top. So if I just open it, I can see this rectangle which would lie right there. And then the wall, one of the wall goes on the other side, one towards my side, one falls to the right, and one falls to the left. So net would look like this. And if we still consider that there is a top, I can attach it to either one of the side. Now this was just a rough drawing. When we do it neat, we will have exact dimensions. For example, let me say this is 4, this length is 6, and the height is 2. So all these are going to be 4. All of these are 2. This is 4, 4. So that's 6, 6, 6, 6, 6. And this is going to be 4, 6, 4. Height is 2, height is 2, height is 2, height is 2, 4, 4, 4. That would be even easier to understand when we draw it on a grid. Just like x-axis, y-axis, Cartesian plane. The following shape is net of a solid that you should be quite familiar with. If we are just looking at it, I can see similar 6 squares. So if we close it, we'll get a cube. What is the main difference between cube and cuboid?
Cuboid is basically a rectangle in 3D, and a cube is a square in 3D.
Okay, that's right. In cube, we have all 3 sides equal. And in cuboid, we may have all 3 different. We may have one different. So that's a cuboid. The diagram shows a cuboid. Draw a net of the solid for the cuboid. Now I can see A, B, and C. Typically, A into B, whatever is at the base, we always start with the center. That is easy to understand. If I just start with this, and why am I drawing it like that? I don't have to make it 3D. Now this is A into B. Now how do we talk about it? Okay, if you can imagine the one at the back side where C is marked, I fall it on the ground. This goes like this. This side is going to be C. Now one face which is towards me, I'm going to bring it down towards my side. And this should look like this. This height is going to be C.
So the top and the bottom both have like A with B, and the sides have A with C.
Yes. Now this side is B into C. So we fall it right there. And same as this one towards left-hand side. And now we are left with the top. We do have different positions where we can draw it. One is, let me change this. If I draw it right there, and dimensions would be A into B. This length is going to be A and this length is going to be B for the top. I can draw it here. Do you agree?
Yes, because the B on the
Okay,
top.
if I remove it from here and draw it here, is this correct?
Yes.
Second position, now I'm changing it again. May I draw it here?
No.
Why no?
Wait, yes, because when you fold it, it would still be on top.
So this is one position, this is second position, this is third, and still we can have fourth position, but
I don't have enough space to draw it there. So anything we draw could be the possible solution, and that is correct. But in exam, we may have a partially drawn net. So we'll have to continue it from there.
Okay.
Question number 2 says the diagram shows the net of solid. Describe the solid as much details as you can. Which 2 points of this are okay. Okay, I'm just looking at the solid and trying to understand where it would close, what 3D shape will it make. And let me enlarge it. Okay. So I can see that this side will paste on this side.
Mm-hmm.
And this UV is going to paste on VW. And can we see through that TU will be pasted on WX?
Mm-hmm.
So I'm looking at this cross section as a trapezium. So when this face closes, this comes over here. This top sticks right there. So it is somehow a trapezoid enclosure. It would look like this. If I can label it, that is slightly bent. Okay. So if I label this Q, this is P, this is O, this is N. And it would be like that when we finish it. So we have this base right there. And then we have this small side, which is on the back of it. Then we have this side, which is at top of it. We're already having the base at the base. And then this NMZY is right here, this slanting side. So we're done with 1, 2, 3, 4 sides and 5, 6 on the either sides. So we may be asked, 99% of the time we are asked to draw a net or a
So
partial net.
it's gonna like basically ask us to draw the 3D shape it makes.
3D shape would be given and we'll be asked to draw the net,
Okay.
just like this question 1.
So describing it as like in as much detail as we can. That would be
Describing
like,
this question is for understanding. This is class exercise, but in exam, we mostly have questions to draw the net.
okay.
This is for understanding for discussion sake. Okay, which 2 points will join point M when the net is folded? Which points will join M?
Well, N and O.
One is O and the other is
N.
N cannot join M. N is somewhere else, M is somewhere else. Is this the correct
Well,
answer?
is that a 5?
S.
Oh, S.
This.
Oh, yes, because from the top it would join it.
Yeah.
When we fold it.
So this
Okay.
QR comes and joins PR, PQ.
Mhm.
And then when this R will actually be at the position of U, P, this S is going to come and land on O. And this M is going to land on O. So M will be joining with O and S. Which edges are certainly equal in length to PQ? Equal in length to PQ.
UV.
UV, right? We have 3 of them.
WV.
WV, that's right. One more.
RQ.
RQ, right? Do you understand the difference between corners, edges, sides? If we talk about this 3D shape, how many corners we have, how many edges we have, how many sides we have?
8 corners?
8 corners, correct.
Edges, we have mm, 12 edges.
Very nice. 12 edges. And how many sides are
6.
faces? So very good. Number 3. A teacher asked the class to draw the net of a cuboid Cerelac box. And these are the diagrams that the student drew. Which of them is correct? Hmm.
A?
Yeah, I think so. A. B cannot be.
And C doesn't have
C
the.
cannot be. Because we cannot have two wide rectangles together.
Mhm.
When we are looking at the Cerelac box, if the flat face is towards us, one is at the back. We
It needs
must,
to have something like separating them.
yeah,
Like A.
something separating them. So that's A. How could you make a cardboard model of this octahedral dice? Draw labeled sketches to show your solution. 1, 2, 3, 4. Hmm. How could you make cardboard model of the octahedral dice? Okay, I'm trying to understand what the question is asking because we may have 8 equal triangles.
Mhm.
Let's say we have 8 equal equilateral triangles individually and we paste them together with glue or tape. But what if I consider this face attached with this?
Mhm.
Just like this?
So
I'm trying to draw it neat. Let's say we start off with this, and these are uncut pages. Now we know that they are equilateral triangles. And if I just continue on the other side and draw one more equilateral triangle, this has to be better for imagination.
and then
Now
afterward, yeah, it
let's
continues.
actually name them. Let's actually name them. This one is 1. This is 2. That's 1. That's 2. And this right next to 2, let this be 3.
Mhm.
That is uncut. That is possible. Now this needs to be folded inside. And when we fold, and if I just look at this shape right here, looking at 3, and I'm going back at the back to look at this shape 4. So this is 1, this is 2, Okay, 1, 2, 3 goes right there. You can fold that 4. This has to be with this side. I'll draw a few lines and erase when you confirm them. This line, is this the one between 1 and 2?
Yes.
Okay. Now between 2 and 3, is this the line which we are considering between 2 and 3?
Yes.
Now between 3 and 4, is this the line?
Yes.
I have to draw 4 there and not here.
Mm.
If
So
that's the line with 4, because 3 will go inwards and 4 lands on the opposite side. So what have we done yet? 1, 2, 3. And if I just look at this side and look at the face at the back and number it 5, this side is right here.
right beside it, yeah. But
So
how's
take your
the
time.
foot on top? Wait,
We'll
could you
come there.
explain?
We'll come to that side one by one.
Mhm.
Do you agree that fifth side could possibly be here?
Yeah, because it's beside them.
So this is number 5. Now we're done with all those 4 at the bottom and 1 is at the top. Now if I look at, let me get rid of these.
Wait.
If I look at this face,
Mm-hmm.
is this the one?
Mm-hmm.
And may I have a triangle right there and number it 6 at the back side?
Mm-hmm. Be
So
right
this could
beside.
be 6. Now if I'm looking at the same one, I know that this was between 1 and 2. This new side is between 1 and 6. The unknown side is going to be between 1 and 7.
Mm-hmm.
So we can draw 7 right here, which is this face out of the page. And now the last face.
Drawn beside 7.
Besides 7. Now it is our choice. We make it with 6 or 7.
Mm-hmm.
So this is the side which is with 1 and 7. We can see it on the 2D shape. And this is going to be between 7 and 8, which is this right here. So it's our choice. We consider it with 7 or we consider it with 6. So that's it. This is just the class discussion. In exam, this is not the difficulty level. It is just still the cuboids and kite, tetrahedral, and trapezium.
When you fold it, it'd be the octahedral dice.
The hedral dice.
Okay.
Why do we call it a dice? Oh yeah,
Because
six-sided
you
die or octahedral dice. You see this Cyrillac box? We could have different orientations for this as well.
yeah, like for example, one of the top parts could be in front of each other.
Yes. 1, 2, 3, 4. And bring this here and take that over there. Is this possible? Or this
Yes, it is.
again? Smaller, wider, narrow, wide, 1, 2. Is this one possible?
Mm-hmm.
And again, smaller, wider, narrow, wide, and we bring this here, we take that there. So all 3 are possible. So this we may have different options and they may be correct.
So could we have continued it like the 1 and 2, like and the 3 beside it? But then we put like something on top of the 3, like another triangle on top of the 3?
I cannot put it on the right hand side. Why so? Why so? If I like, if I'm getting it right, are you asking about this triangle?
Yeah.
Okay, now see. This is 160 degrees, another 60 degree, another 60 degree. That is 180 already. Now see, this is 1, the fingers are 1 and the palm is 2. And let my thumb be the third one, which is attached with 2. So 1 twists inside, this is 2, and when 3 is coming here, 3 actually joins 1 on the other side at the lower end. That is at the lower end of 1. 1 stays there, 2 comes here, and 3 is coming inside. Let me try. You see this side, this is between 1 and 2. This is 1, this is 2. The upper right top corner of 1 is this. The lower bottom corner of 2 is this. Now the sides joined between 2 and 3 is this right here. And when it is actually coming inside, if you draw this triangle here, that will join with 1. If we draw one triangle here, that will join with 1. And if we don't do that, and the other option is 4, that is coming in the same case that is coming right here. There was one software, GeoGebra. Have you ever heard of that?
No, I don't think so.
I've actually uninstalled it. And at times I was using this as a 3D software. When we'll study circles, we can use these animations. And I'll install it again and I'll show you the animation to understand that.
With the net. So it doesn't only have circles?
It has many things.
Hmm.
One version was 5, one was 6, I think. 5 is the one which will solve our applications. This. Download. Okay, now this is downloading. I'll inshallah do it. Like I'll have to see on YouTube how to do it. I'll show you the animation and it will be very much easier to understand.
Okay.
If I can quickly find. Yeah, this one. I actually used it once for these shots.
Just look at this shape carefully.
Can you see that closing?
This is how it looks like when it
So
is
the cube goes
closed,
there,
and this is
and
how
when it
it will
lands
look
back.
like when it is open. And it may have different patterns. So you see where these shapes land when they close and where they land when they are open. Out of a cube,
That's
we'll
repeating.
just look at this shape carefully. This is how it looks like when it is closed.
I had this in mind. I just forgot that I've
This is
already
how
made it.
will look like when it is open. And it may have different patterns.
So you can
Okay.
also do one with the dice.
Yeah, I did that once. It was getting very hard to explain and became easy to show when it you can visualize it.
Hmm.
And that was easy to understand. Surface area and volume of solids. Now, again, surface area, volume is a different thing. Surface area is going to be the composite shape, not exactly the composite shape. When we look at this cuboid, we know that we have 6 faces. So what we can do is we can find 6 different areas and add them,
You have
but
all the faces.
all the faces. But before we do that, we already know that area of this face at the bottom is equal to the area at the top. And we know that these 2 areas are equal
Mm-hmm.
and one at the back and at the front. So we have to find 3 areas and we can multiply them into 2. So what those 3 areas could be, that could be length into breadth at the base. It could be plus the one with the height, that is base into height. It could be the one at the back, which is going to be length into height. You see, we multiplied length with breadth and length with height. Length with both of these. Then breadth with height and breadth with length, both of these. Then
Mm-hmm.
height with breadth and height with length, both of these.
Mm-hmm.
Like if I have dimensions 2, 3, and 4. So what I'll
Yeah.
be doing, I'll be multiplying them with each other. 2 into 3 plus 2 into 4 plus
Mhm.
3 into 4. Everyone with each of the other. I'm done with 3 sides into 2 gives me 6 sides. So these 3 sides into 2. This is the formula for cuboid, total surface area. Total surface area of cuboid is 2 into length into breadth plus length into height plus breadth into height and this. These are 6 sides.
Okay.
Well, this right there. And volume is basically length into breadth into height. We already did the area section right here. Remember these areas?
Yes.
Now, if you allow me to convert all of these areas into volumes. Oh, we have already discussed them. Do you remember?
Yeah.
I
So
can give a quick recap.
volume.
Cross-sectional area into height. If we have this square, and let me say this is the new shape. So cross-sectional areas are already there, and I'll multiply it with this new height. Cross-sectional area is already there. I'll multiply it with this new height. Cross-sectional area already there. We can multiply it with the new height or new length, whatever
Wait, and
we
this
call it.
also work for like a pyramid?
Yes.
Okay.
Pyramid would be the one which converges at the top, or we call it.
Yeah, I think we had one like it was with like a cone.
I'll show you the difference. One of those shapes is this square at the bottom, but it converges at the top. This is the pyramid. And when it is not converging at the other end, this is the prism. This is pyramid, that is prism.
Prism. Yeah.
The volume is cross-sectional area into height. We can take any cross-section, this cross-section into this height, or we can take this cross-section into this height. If I look at this shape, now this is an irregular shape. So if this cross-section is given to me, cross-section into height, which side can we take as cross-section is the one if we have this same shape on the other end. So that's our cross-section times height. Again, cross-section into height. Cross-section into height is volume. Cylinder's cross-section. Cross-section is a circle, pi r square times height. Now, total surface area of the cylinder. If I open this up, if I cut it into two parts, just
It'll be
like this.
with two circles at the top and the bottom.
Yes. So if we have this cylinder and two top and bottom are clearly two circles, so I can draw this top and this bottom, and then this part at right here, consider that there is no top and no bottom. Now I'm using a pair of scissors and I cut it right through this length. And when we do so, let's say it opens up like this. And then we hold these two up and open them apart. When we keep opening it, it gets wider. And finally, at one stage, it will be a straight plane. Now, may I say this height is the one same as this?
Yes.
And may I say this complete circular length is same as this? May I
Yes.
say this was the circumference and this is the circumference?
Mhm.
So area of this sheet, area of this circle is pi r square. Area of this second circle is pi r square. Area of this sheet is going to be height into circumference. And when I go back, may I say circumference is 2 pi r?
Mhm.
So this is the total surface area of cylinder, that is 2 pi r square, two circles, plus curved part 2 pi r h. Don't get it confused with volume, which is pi r square h.
Yeah,
That
two
is cross-sectional area into height. And this is 2 pi r is the circumference into height, pi r h. So this was 2 pi r h plus pi r square plus pi r square.
2 pi r squared plus 2 pi r h.
Yes, pi r square plus 2 pi r h. Okay, find the volume and the surface area of the solid with nets shown in the diagram. Looking at question number 1, what would you do first, area or volume?
I would do the surface area first
Okay.
because I can just add them all together. So, so what I have is 6 plus 6 plus 55 plus 33 plus 44.
Where is this 6 coming from?
The 6 because the triangles. 4 times a 3.
Yeah,
and
very good.
12, yeah.
Okay. I was actually looking at the numbers. You're talking about the area. That's right.
I got 144.
Oh, very good. When you talk about these sixes, how do you get the remaining areas?
Of the other shapes?
Yeah,
Oh, well, for the one like going through the middle of them, it's 4 and 11 because the one on the side is the same length
very good.
on the other side.
So you did 5, 11, 4, 11, and 3, 11.
Yeah.
That is completely correct. We're just
Okay.
discussing, may I do it 12 into 11 once? May I consider this one large rectangle?
Mhm.
And then you already told me that this is 6 and that is 6, 144. The purpose just to discuss this is to give you two thinking perspectives.
It makes it a lot faster.
Yeah. Okay. So volume.
So yeah, this it was like, so we find the shape area of the triangle and we times it by the height.
Area of triangle and times height. Very good.
So, Mm, 18.
This is
Feet of height.
6 into 11.
Mhm. For for me, what I did was I did it like 6 into the 3 because 3 is the height, like the shape. Because the 5 lands on the slant, 4 goes on the
Cross-sectional area. When we talk about the cross-sectional area, allow me to close this shape.
Mhm.
It would somehow look like this. That reminds me of Toblerone. You know what that is?
The chocolate.
That makes brushing compulsory. So this is our cross-section area. If I consider this 3 into this as cross-section, that is the one at the back. And when it comes towards my side, it is getting thinner. But these two cross-sectional areas, the triangle and triangle, it stays the same.
Mhm.
Consider this new candle. And that's the thread. When we burn it, this goes off. Then this goes off. The area is changing. If we look at the top, that would be a circle. And the circle area of circle is increasing until it reaches this point. Now, after this point, it keeps on melting, but the area is not changing. So where the area stays same, we consider that as cross-sectional area. So we consider these triangles as cross-sectional area into distance between them, which is 11. Clear?
The distance between them?
Distance between them, yes. This distance is 11.
Why do we do distance?
We call it height or length or distance.
Oh,
It's the same. Volume equals area of cross-section into height. Let me
yes. Yeah.
go back onto those shapes. You see, for the volume, we do this area of cross-section at the base because it is the same at the top, and we multiply with the distance between these two parallel sides, and we call them height or length or distance. Area of cross-section at the bottom is length into base, and
Yeah,
then
yeah. Between the two shapes, so yeah, the distance
the two
between them.
shapes.
Okay.
This is the area of cross section and distance between them. You
For
either
me,
call it height.
I was doing like the distance between like the bottom one and like the one of the shapes, like the triangles. I was not doing between the
Yeah.
two distances.
It is
Okay.
between those two triangles.
Okay. Yeah, 6 times 11.
Question number 2. Find the volume and the surface area of cuboids with the following dimensions. Now we have the dimensions already and they are cuboids. So volume is length into breadth into height. So 5, 8, and 18. 5 into 8 into 18. That's it.
So 720.
7 and 20. And the unit is centimeter cube. On
And
the other
then
side, when we talk about total surface area, first put in
2
the
pi r squared plus 2 pi r h.
we are talking about cuboid, not cylinder.
So cuboid. Oh yeah, the length times width and then the breadth times height. Yeah, okay.
So
Okay.
2, 5, 8,
5, 8, yeah.
8, 18, and 18, 5.
$274.
Try 8 into 18 plus 18 into 5.
Oh, and then times it by 2. So 548
Yes. And the unit will be
centimeters cubed. Squared.
cube is volume
Uh-huh.
and surface area is squared.
Okay.
The diagram shows a bottle crate. Find the volume of the crate.
It's 486 400,086 hundred
3, 2, 1, 2, 3.
43.
Volume.
Mm-hmm. Yeah, 432.
Centimeter cube. The diagram shows a pencil case in the shape of the triangular prism. First one, calculate the volume. Which side will you consider the cross-section side?
The triangle.
Very good.
— 1,280.
768. Which dimensions did you use? Did you use 1 by 2?
By 2. Yeah.
Area of cross-section times height.
Yeah, 768. Maybe I typed it wrong into my calculator.
Dimensions were correct.
Yeah, dimensions are good.
And centimeter cube.
Surface area.
Now total surface area. How many faces do we have?
4, 5.
5, yes. In any order.
Okay. $816.
816, correct. So when we are talking about 5 sides, this is one side, which is 24. There is one triangle at the back, that is again 24. And we have 3 rectangles. One is 6 into 32. The other is 8 into 32. The last one is 10 into 32. May I just consider that when we will open this up, it will be 8, 6, and 10 into 32.
Mm-hmm.
And if I just add 8, 6, and 10, it is 24 into 32. And we get the same answer.
Mm-hmm.
We may have different approaches. We'll get the same answer. We're just discussing it. This is not compulsory. Any method you choose is allowed. Okay. The diagram shows cylindrical drain. Calculate the volume of the drain. Now this is circular cylinder.
Wait, is that supposed to be the diameter of the circle? 1.2?
Yes, that's the diameter. What is the formula you're using?
Well, pi r squared for the circle times the height.
Very good.
I got 3.4.
Pi into r square into h is yes, 3.3929. We will write it up to 3 significant figures. 3.4 is correct. Meter cube.
39 meters cubed. Yep.
The diagram shows a tube containing. Okay, now these questions, when we will keep on practicing, they will lead onto the stage when volume will be given and one of the dimension will be missing. Or surface area might be given and dimensions missing. The diagram shows a tube containing chocolate sweets. Calculate the total surface area of the tube.
76.72.
Yes. 76.72. Yes. When we wrote this answer, I said three significant figures. And when you say 76.72, that is four significant figure and
Mm.
two decimal place.
Mhm.
Okay, so mostly examiner asks about the
Great.
significant figures.
Okay.
That
So,
would be given in the question or at the start of the paper.
okay.
Degree of accuracy will be given. The diagram shows a solid glass case for a clock. The case is a cuboid with cylinder removed to fit the clock mechanism. Calculate the volume of the glass required to make the clock case. Now we are moving towards composite shapes.
Do we have to find the volume of the cuboid?
Volume of the glass after removing that part.
Oh, okay. So we just have to subtract the volume of the glass with the cylinder.
Yes.
Okay. Wait, does the cylinder go all the way at the back of the glass?
Yes, it goes throughout the glass.
Oh, okay, okay. $24.1? No. Wait, I wrote that wrong, sorry. Yeah, 241.4 or 241.5.
8 into 10 into 4 is 320 for this complete. And
Mhm.
volume of cylinder is going to be pi r squared. So pi into r is 2.5 squared, and then we subtract these two. So I can write 320 minus pi into 2.5 squared.
Don't we times like the pi r squared afterwards with the height, the h?
Yeah, thank you so much. Pi r square h. You saved the day. Into 2.5 squared into height. 241.46 or 241 centimeter cube. Three
Mhm.
significant figures.
Okay. Mhm.
If the examiner would say, give your answer to two significant, this is three significant. Up till two significant, we'll be writing 240 because this one won't convert that
Okay, so we just write 240
and
if
we
you
write
want.
that 0.
Okay.
A storage company has a regular storage area of 20 meter long by 8 meter wide and 2.8 meters high. Find the volume. How many cardboards? Okay, now this will be interesting. Because sometimes it is not occupying all the space.
448.
448 meter cube. Yes. How many cardboard boxes of dimension 1 meter by 0.5 meter by 2.5 meter can fit into this storage area?
Uh, 358.4. I mean 359.
How did you do that?
I just found subtracted the volume of the storage area with the volume of the cardboard box.
But we are not placing one cardboard box. We are pushing in the cardboard boxes in the storage area.
Yeah, so wait, did
see?
I say subtract? Did I say subtract?
Yeah, you said subtract. Did you
No,
mean divide?
divide. Yeah, I meant divide.
You
But
can't do that.
we can't?
No. We have to think, because these cardboards are not like what do I call, soft toys, which we can actually push in. These are not soft toys. For example, if I have one shoebox and I have tennis balls, so I cannot divide these two volumes, because when I'll fit in the tennis balls, we'll still have voids in them. We'll still have free spaces in them. So if I talk about this storage area, this is 20 meters, height is 2.8 meters, and this is 8 meters wide. Now you see, the boxes which we have to place are 1 meter, 0.5 and 2.5. So let me say I place this 2.5 right in this direction, and this is the height, and 1 meter in this direction and 0.5 in the other. So this is going to be 1, this is going to be 0.5. Now this is 1, and it will place 20 of these boxes in this line, if that is 1. Now this is 0.5. This will place 16 of these boxes on this side. And at the top, 0.3 meter is going to be wasted. We cannot push in any box in that space.
Can we also do it like with the surface area? Would that also work?
Surface area will not help.
Okay. So we have to do like individually, like
Individual.
the 8 with the 16. Okay.
Just imagine this thing. This is 0.5 wide, 1 meter, 1 meter, 1 meter, and these are 20 in this direction. And how high is it? It is 2.5 meters high. And the storage area was 2.8. We can rotate the box. We can see if we can fit maximum on the other side. If I bring it this way, this is going to be 8 boxes this way. If I bring 1 meter on this side, lay it this way. And now it is going to be 40 on the other side, because that is 0.5. So we can fit in 40. Now these are 8 and 40. What the height will be? Height is still 2.5. So we multiply 40 into 8, we get 320. Or we multiply 16 into 20, we still get 320 boxes.
Total
And if you
300.
would try to fit in the other way around, like the 2.5, we will never fit in the 2.5 in direction of 8, because 2.5 is 5, and then 2.5 again is 7.5. It will waste 0.5 meters. So that is 7.5. If we place it that way, this is going to be 3 plus 2.5 plus 2.5 plus 2.5 are going to be 3 boxes this way. And if we place now 2.5 lays on the other side, and we are left with 1 and 0.5. So if I put 1 on this side, this is going to be 20 boxes. Now 20 into 3 is 60 boxes this way. And the height is going to be 0.5. To fill this 2.8, we are taking 0.5, 0.5. How many can we fit?
About 5,
We can fit in 5.
and
So
then the left.
60 into 5 gives me 300. So it wastes more space. In the previous assumption, we were getting 320. And this
Three.
new orientation, we are getting 300. Because at the end, again, point 3 is left. Point 3 is left at the top because it was 2.8. And this 0.5 meter is also left because that was 8 meters, which is also a waste.
Mhm.
And we can fit in the vertically. If I like switch the orientation, these are 2.5 and then 1 in 2.5, and we switch this direction 2.5, 2.5, 2.5. So that will be one hectic task. If we miss any one of the corner, we'll miss the correct answer. We can fit in 20 boxes vertically and all other are lying horizontally. We still have 320. Getting confused.
No, we're basically just like changing the way it stands so it can fit more boxes into it. And it'll
Yeah.
both be 320.
Consider
Okay.
your shoebox and a matchbox.
Mm-hmm.
So we can try different orientations. We can lay the matchboxes in the shoebox or we can make them stand.
Mm-hmm.
And we can see which way it fits within more number of matchboxes.
Hmm.
What is the surface area of each cardboard box? So simply plug in the formula. 2 into 1 into 0.5 plus 0.5 into 2.5 plus 1 into 2.5.
Oh wait, the shoebox?
Cardboard box.
Oh, cardboard box.
Dimensions are in B part.
Cardboard box. Wait. Oh yes. Yeah. 8 point. Eight.
How do you pronounce this first word? Mio? Bio?
You?
Mio.
Oh.
No. Mio is moving to Brazil for his new. Okay, that was someone. I thought this is something. Is moving to Brazil for his new job. He has hired a shipping container of dimensions 3 into 4 into 4 to move his belongings. Calculate the volume of the container. Length into breadth into height.
48.
48 meter cube.
Yeah.
He is provided with crates to fit the dimensions of the container. He needs to move 8 of these crates with a volume of 5 cm cube. Will they fit into one container?
So now they're giving us volume. So we can not do it like one by one anymore. Basically.
That's a mix of quantitative and qualitative question because all the dimensions are not given.
Mhm.
So we may consider some of the given data and give a statement.
Mhm.
He is provided with crates to fit dimensions of the container. That would obviously mean that no length is more than 4
Mhm.
because his container is 3 meter by 4 by 4. Consider that the 4 by 4 is a base and 3 is the height. So if we have a crate which is like more than 4, we cannot fit in. So if the volume is 5 already and we have 8 such containers. So 8 into 5 total volume is 40. So yes, we can fit.
Oh, okay. Okay.
Pyramids. A pyramid is a solid with a polygon shape, base shape, and triangular faces that meet at the point of the apex. Now, anything which will meet at the apex, like we could have a triangle at the base and pointed at the top. We could have a square at the base and pointed at the top. Or we could have anything at the base and pointed at the top. For example, let me say irregular, star shaped. That is also a pyramid. So volume is going to be, now what is the difference? Area of base is already there. Perpendicular height is already there, which we've been doing. That was cross-sectional area into height. We're just adding 1 by 3 to it. So
Okay.
cone, what was the volume of cylinder?
It was just basically cross-sectional area still, and then height. So
Yes,
pi r squared times height.
pi r squared times height. Now we are talking about this pointed end. So what do? We just add this 1 by 3. It actually reduces the volume by 1/3
Mhm.
to 1/3. Curved surface area. Okay. The same way we cut the cylinder into pieces and we got 2 circles at top and bottom and then a flat part. So if we split it into 2, we may get one of the circle. If there is a bottom, we will get one of the circle and the other is this part right here. So these two were joining together to make it a cone.
Mhm.
So we remove one of the section. What am I doing? Okay. So this is the angle. How do we find this total surface area? If we just have the cone, the top part is going to be pi r l plus the base is going to be pi r square. L is the slant height,
Mhm.
this right here.
So
And
that's the net of uh the pyramid.
yeah, curved surface area of the pyramid. We call this
Mhm.
curved. Whenever examiner will ask you curved surface area, he's talking about only this angular part. When he talks
Mhm.
about total surface area, then yes, we add pi r square. Other than that, you don't need it.
So curved surface area is just that one, the net,
That's the
like that.
pyramid part without the base.
Mhm. And then
That
the
is,
total is that one, like the
yeah,
shape.
it has to be given that it has a base. For example, if we are talking about a birthday cap,
Mhm.
that is understood we do not have any circle attached at the bottom.
Mhm.
If we talk about a birthday cake, yes, it has a bottom.
Mhm.
Okay. So we're adding shapes. And when we add the shape, let me just write it here as summary. A cone, total surface area, and volume. When we are talking about the cone, total surface area is pi r square plus pi r l. and volume is 1 by 3 into area of base into height. And when we are talking about this three-dimensional ball, total surface area is 4 pi r square and volume is 4 by 3 pi r cube. Same way, this is called sphere.
So for a sphere, it's 4 by 3
Volume
instead
is
of
4
1.
by 3, yes.
Mhm.
The hemisphere would be half of that. So when we talk about this, volume is straight away 2 by 3 pi r cube. Any issues in 2 by 3 pi r cube?
Mm.
And total surface area. This is going to be pi r 2 pi r square plus pi r square and overall 3 pi r square. Consider an apple. If you have an apple and it is red at all sides, so red area is going to be 4 pi r square. But when you split that apple in half, now this top red part would be 2 pi r square. And you see that you have generated one white section. That is a circle plus pi r square, making
So
it
it's
3 pi r square. Now the quadrant, fourth part of this. Let me try and draw. So fourth part of it. So straight away volume is 1/4 of that. 1 by 3 pi r cube. I've just divided this by 4. Or let me write 1 by 4 of this complete. And we can simplify it to 1 by 3 pi r cube. On the other hand, this section is fourth part of the curved, that is pi r square. That was 4 pi r square initially.
Mhm.
And this new generated phase 2 semicircles make one complete circle, making it 2 pi r square. So it is always better that we split these shapes and then solve one by one. So total surface area is 4 pi r square and volume is 4 by 3 pi r cube. The diagram shows a beach ball. Find the surface area of the beach ball. So 40 is given. 4 pi r square. Radius should be 20. So 20 into 20 into 4 is giving me 1600. 1600 pi centimeter square. And
So
when
5026 point 5.
0.5. Yes. Okay. Now do one thing. State the degree of accuracy yourself, decimal place or significant figure, anything, and we'll write the answer.
Degree of accuracy, like how accurate my answer is?
Now, what should we do? You're the examiner. You're asking that write your answer up to how many significant figures? Select any.
5 significant figures?
So this is the answer.
Yeah, basically.
So if the examiner would say 3 significant figure, what will you write?
5020.
May I write 5030?
Well, wouldn't that turn like the 0 to a 1, but then the 1 can't turn the 2 into a 3?
We are talking about 3 significant. Let me write it separately. So when we are talking about 3, we are concerned with these first 3 digits.
Oh, wait. Oh, sorry. No, because I saw like the 6 as a 0 for a second.
That's it.
0,
So
yeah.
if I have to write it 2 significant figures, this original answer, what would I write?
5000.
5000. So this is what I was expecting, that select any degree of accuracy and then we'll write that answer.
Okay.
B part says find the volume of the ball beach. 4 by 3 pi r cube.
$33,510.3.
Very good. Write it up to 3 SF.
Oh. 33,500.
Yes. Let's do one more. Question number 2. The diagram shows a metal ball bearing that is completely submerged in the cylinder of water. Find the volume of the water in the cylinder.
Hmm.
What
So
would be the approach?
I would first find the volume of the metal ball and subtract it by the volume of the water that is given inside the
The
cylinder.
cylindrical shape, and we'll be left with the volume of water. That's right. Are you using scientific calculator?
No, because that one I need to charge it.
Okay.
Yeah.
It's not an issue, but one day you will need to switch to that because we will be studying trigonometry.
Yeah. 5,220 yeah, 5,297.2 3.
Right. And what do we write at 3 significant figures?
500 and no 500 5,300.
Very good. 5,300. Because we were bound to write it as 3. We cannot write 9 as 10. We'll continue from here tomorrow. And I didn't get that test.
Okay. So you're gonna send me the questions from like the rest?
I know the one we had as a short test.
Mm-hmm. Yes.
I didn't get it to check.
Oh. Um,
Sure.
I think it was sent.
This one.
Yeah.
Well, let me quickly see if I
Okay.
it. No, I don't have it. Make sure you sent it to me.
Okay, I have the papers with me right now, so I'll just send you the picture of it.
Sure, sure.
Okay. Okay, sorry about that. I can, I'll send it again.
Sure. You did these questions?
Yes, those ones.
Yeah. Two more, then we'll start the new topic.
Okay.
Question number 8 says a 32 centimeter long cardboard postage tube has a radius of 2.5 centimeters. What is the exact volume of the tube? So that is a cylinder. Pi radius is given and height is given.
Six hundred and 28.3.
Yes. 0.3 centimeter tube. B part says for posting the tube is sealed at both ends. What is the surface area of the sealed tube? So we're talking about total surface area of cylinder.
It was 2 times pi r squared plus 2 pi r h, right?
Correct.
Okay. One thousand 759.3.
1000.
Mm-hmm.
2 pi r square plus 2 pi r h. I'm getting 541.
Hmm. Oh, I was doing the 2 pi r squared, like after I got pi r squared, I timed, well, should put the same thing.
So
I'm
this is
gonna do it again.
one circle at the bottom, one circle at the top. That is making it 2 pi r square.
Mhm.
And by the way, you did an excellent test. There was no mistake. And
Thank you.
just in case for next time, few questions I might have mentioned about working.
Yeah,
That
the
let me
interview.
know what method you are using.
Yeah.
So that is why sometimes I discuss 2 or 3 different ways how to do it.
For this one, not like I did it with the two, but before I was doing it as like the past answer, but yeah, I don't think I was doing it correctly.
Okay,
So
see, this is the cylindrical shape, and I'm breaking it into 3 different parts. One,
mm,
second, and third part. First part is a circle. Second part is again a circle. So we have 2 circles. That is pi r square 1 circle times 2. And the curved part right here is 2 pi r h. So 2 pi r h. And then we just fit in the values of r and
yeah,
h.
now that I did it again, yeah, I got 542.
The ninth says a hollow metal tube is made using a 5 mm metal sheet. The tube is 35 centimeters long and has an external diameter of 10.4. Draw a rough sketch of the tube and add its dimensions.
Well, it has no like the circles on the two bottom parts.
Yeah, that's an open tube.
Hollow. Yeah, it's just hollow.
Yeah.
It's 35 centimeters long, so and then at 10.4. Well, drawing it is easy, kind of. It's just you have to place it. I don't know if you can see from my computer. Like,
Yeah, it looks like that, but I'm unable to read the dimensions. I'll quickly draw it. So basically, we are having a cylindrical shape in which we know that the length is 35 centimeters. So I'm labeling this as 35 centimeters length. And then I know the exterior diameter is 10.4. So I may label this section as 10.4 centimeters, right?
mhm.
And we know that the sheet is 5 mm thick. So what if I draw an interior circle as well? So it's like that. And I may say that the interior diameter is 5 mm plus 5 mm makes it 10 mm, which is 1 centimeter. So that is 9.4 centimeters.
Wait, why are we adding the 5 millimeters?
Because it is the thickness of the sheet.
Mm-hmm.
Just consider a water pipe, which we'll use to water the plants. The pipe has a thickness. One is the external diameter, one is the internal diameter. The external diameter of the pipe right here is already 10.4. And we know what is the thickness of the sheet. This thickness right here is given 5 mm, so it would be same on both sides. So
Mm-hmm.
overall it reduces by 1 centimeter. So internal diameter is 9.4 centimeters.
Mm. Okay.
It's 10.4 internal, 9.4. Now write down all the calculations you will have to make to find the volume of the metal in the tube. Volume of metal in the tube, the material.
Well,
What will
I think you can first find like the normal one without the thickness included, and then subtract it by the smaller circle, like this the
yes.
one that it makes.
One the complete section and then we subtract the hollow section.
Mm-hmm.
That's right.
544.3.
Very good.
Yeah.
C part says calculate the volume of metal in the tube. What's the difference? Right.
does it get
Okay,
thickness?
sorry. We have already done that. I just
Oh.
reread the question and I'm saying what's the difference. So we just did that. And B part was write down all the calculations you will have to make. So that was like the external volume and the internal volume. D part. How could you find the total surface area of the outside plus the inside of the tube? Total.
Does it ask us to give it the answer or just tell it like show the steps?
We'll actually find it.
Okay.
Yeah. He is asking like how you'll do it. But just to ensure that we are both thinking the same thing, we can match our numerical values.
Okay.
So how can we find the total surface area of outside and inside for this shape?
So, well, we can add them together. We could first find the outside cylinder, like the larger one, without the thickness, and then we can add it to the smaller one on the inside with the
That's,
thickness, like the inside one.
that's right. So total surface area.
Is it 2485.8?
2000 how much?
485?
I'm getting 2192. Let's discuss.
Okay.
Okay, one thing is I use this capital R and this small r just to differentiate for myself. There's no restriction in Cambridge. When I'm using capital R, I'm talking about the outer radius. So outer surface is this. Inner surface is this. And then if I just shade this in green to differentiate, then I'm talking about this ring. And yes, while I'm shading, I just thought so that it is on both sides. Let me quickly do it. We may have same answers. So into 2, into 2. 77.12 plus 15.55 into 2 is 2208.22 centimeters square. What was your answer?
2485.8.
4. Do we have the first line as same? 2 pi r h outer, then 2 pi r h inner. Do we have the same radiuses? 5.2 and 4.7.
Mm-hmm.
And then pi r square for the larger circle and minus pi r square for the inner circle times 2. I'm rechecking it quickly. 2 pi r into h plus 2 pi r into h plus 2 into pi into 5.2 squared minus pi into 4.7 squared.
I wasn't subtracting the two. I wasn't subtracting the pi r squared with the other pi r squared.
You have to subtract it because inside is hollow.
Mm-hmm. Oh.
This white area is this thing.
So we have to subtract. Okay. Okay, I think yeah, that's where I messed up probably. I was not subtracting them.
Let me quickly change the sign to positive. If I do that, yes, we are getting 2485 if we add them, but we have to subtract.
Okay. So no adding them.
But this topic is complete. We can now move on to the next topic.